calendar. Yeah, here we go. So let's take a look at Advent of Code 2022, day 14. Actually, let me take a look here. So I think we crossed the bridge. We fell off the bridge, right? And then we're walking along the riverbank. And it looks like we kind of see the elves going in this direction, maybe. And then we'll lose track of them because we only see green around here. So I'm assuming that once we'll find some elves at some point and meet up with them and then get the map filled in. I don't know. But I think they're going this way, and then we kind of lost track of them for at least 2 days. So let's see what today brings. Maybe we're going to find them now. All right. Day 14, Regolith Reservoir. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself. That doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Aha. Correction. The distress signal leads you behind a giant waterfall. There seems to be a giant large cave system. Oh, sorry. No giant. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Uh-oh. We're getting flashbacks to Outer Wilds now. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. What is this? This is 2018, day 17, which we haven't gotten to yet. You scan a two-dimensional vertical slice of the cave above you, your puzzle input, and discover this mostly air with structures made of rock. Your scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path, where X represents the distance to the right and Y represents the distance down. Huh, okay. But it's above us, but Y represents down. Okay. So we must know where the top is, right? Each path appears as a single line of text on your scan. After the first point of each path, each point indicates the end of a straight, horizontal, or vertical line to be drawn from the previous point. For example, this. Oops. So this seems like pretty straightforward. Let's grab our input. Get input 2022, day 14. Okay, so it's a bunch of these. There's 152 lines. Looks like the X coordinate is mostly in the 400 to 500 range. And the Y coordinate is... All right, well, we'll see. We'll see what it looks like. This scan means there are two paths of rock. The first path consists of two straight lines, right? So from here to here and then from here to here. Specifically, the first path consists of a line of rock from there to there and another from there to there. Sand is pouring into the cave from point 500, 0. Drawing rock as hash and air as dot, and the source of the sand is plus source of the sand. Oh, okay, that's right, because sand is pouring in from the cave, but I guess it's there's only one point it's coming in from. The sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. Oh, that's very nice of it. A unit of sand is large enough to fill 1 tile of air in your scan. A tile of air. Now there's a descriptor. A unit of sand always falls down 1 step if possible. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to instead move diagonally 1 step down and to the left. If that tile is blocked, the unit of sand attempts to move instead diagonally, I didn't say that right, 1 step down and to the right. Sand keeps moving as long as it's able to do so at each step, trying to move down, then down left, and down right. Okay, I get it. If all 3 possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. All right. So drawing sand has come to rest at 0, or sorry, the letter O. So it just drops there. Okay. Second unit drops there, and so on. After 22 here. Finally, only 2 more units of sand can possibly come to rest. There and there. Okay. Once all 24 units of sand shown above have become to rest, all further sand flows out the bottom, falling into the endless void just for fun. The path any sand takes before falling forever is shown here with the tilde. We can kind of see that coming down here. Okay. Using your scan, simulate the falling sand. How many units of sand come to rest before sand starts flowing into the abyss below? All right, so we did have some test input, right? Right here. Let's use this as our test input. just like that. And then we'll create our new file. Oops. Grab this one instead. Change that to 14. 14. Two more 14s. Oops. And then we'll finish out this line with mutt day 14. All right. Create it. Jump to it. Let's see. I should automate all of this, right? Oh no, over here, well, let's run bacon. And I messed something up. No, I didn't save this here. That was it. Okay, good. So I think parsing should be pretty easy because it's just looping over these things and then splitting out the pairs. You know what I'm going to do? Let's create a cave struct. And the traditional way to store the cave items is, I don't know, a hash map. Let's do I32, I32. And it looks like we're either going to store a hash or the letter O for sand. Oops. So it's just char. What else do we need? I think that's all we need for now. I might want to store like the width and the height or something like that, but let's cross that bridge when we come to it, when we blow it up. So parsing is let lines lib read lines test input dot text for line in lines. Let's create a cave here. Cave is a cave, which means we have to derive default, and which means we need to import. Actually, you know what? I think the code action should let me do that, right? If I try to build it, it should fail to build, saying we're missing this thing. And if I do a code action, one of the options is import standard collections hash map. There you go. Okay. So now it should build. We get a warning we're not using line anywhere probably. All right, so each line, it can be split up into these things here. So let's say let mutt iter is equal to line.split on this. Right, so now we get all the pairs of digits. And we can just create a draw line. So let start is equal to, let's say, iter next. Let's write a little convert function on the cave to convert it into a pair. And then we can say while let sum end is cave convert iter next, which means this has to be a sum, right? I mean, this has to be an option. So what I want to do is this, and then say cave.draw line from start to end, and then say start is equal to the end, and then it just loops and draws all the lines. So how do we implement this kind of a interface for us? And I think, like I said, I think this, well, first of all, this needs to be mutable because we're going to change it. And then this needs to unwrap because we have to unwrap here. So if I say impl cave fn convert, and it's just going to take a string and it's going to return an option of I32, I32. And for now, we'll just say none. And that should blow up because I'm doing an unwrap here. Oh, right. And we've got to input an option string. And then cave draw line doesn't exist yet. Okay, so we have to add that. Oh, I didn't create a cave. Self cave. There we go. Now draw line doesn't exist. Okay, so let's just create a quick draw line, start I32, I32, end I32, I32. And it, for now it does nothing. I just want to get the basic structure here. Oh, this has to be a self. And it's got to be mutable because we're going to be changing. Okay, we're good. What's next? We got to figure out how to do this conversion. And we're going to say if let sum s is equal to s, else none. All right. And that way this loop will work because the iter next will return a sum. I mean an option, and then we just unwrap it here, and then we can just do this little loop here. This would be let, these are x comma y. Okay, so that's important. It's not row column, it's xy. So let's do everything in terms of xy. xy equals s dot split once on comma, unwrap. And then these should be strings, and then we can just say sum x dot parse dot unwrap y dot parse dot unwrap. That should be that, and that should convert everything. What do we got? Oh, I forgot that this is in a tuple. Okay, so what we should do now, we should be able to do now is print these out. I should be able to say println. Actually, let's print it down out of here, right? That's why we have draw line. Println draw line from start to end. Right, and then we should be able to see those. We're still not using tile, but right, 494, 498.4, 498.6, then 498.6 to 496.6, and then 503, 502, right? Does that look like it's working? I think that looks like it's working. Hakuma Matata says you're also missing out on Rust Analyzer integration. I use it a little bit. I use it a little bit because I can hit Shift K. I've got that mapped to it telling me what I've got going on here, and I think that's Rust Analyzer telling me that. I don't know what else. I mean, I'm sure there's other things I can add to my config that'll allow me to speed things up a little bit more. So if there's some particular Rust Analyzer thing that you'd like to see me try using, I'm happy to try using it. Let's solve this day first, and then we can play with that. So now we just need to figure out how to do draw line. So draw line should be pretty easy because all we're going to do is insert the characters into the hash map. Let dx is equal to end.0 minus start.0 dot signum, and let dy is equal to end.1 minus start.1 dot signum. Okay, and now we're going to draw from start to end and modify the point we're drawing by dx dy. So let mod point is equal to start self dot tile dot insert point hash while start is not equal to end. No, point is not equal to end. Point dot 0 plus equals dx. Point dot 1 plus equals dy. Self tile insert there, and then we're done. Now, how do we know if it worked? I guess I could just dump out a little bit. I can dump this out from 494 to 503. I can print out what it looks like. Let's do that. For y in 0 dot dot equals 9. For x in 494 dot dot equals 503. Print bang if self tile contains key xy. Then we're going to say print. Oh no, it's just hash. Else. Can we do this all in one line? Dot. I don't know if it's going to reformat that. Then println, and then we're done. Okay, so let's see what that does. Kaboom. Oh, cave tile. There we go. I think this works, right? I mean, this looks like it's working here. I see the little L. I see this little jiggity jag thing. Okay, so I think we're parsing correctly. Let me put this in a comment in case we want to use it for the real input. Okay, so now what we need to do is drop a piece of sand. How do we drop a piece of sand, right? We need to figure out going straight down. So part 1 is going to be let mut part 1 equals self cave clone. I'm going to clone it here because I'm probably going to need it for part 2 as well. That's the way these things usually go. So let's try dropping. Actually, you know what I can do is let me move this code into a display output here. So let me say print, fn display self. And then we can just dump this out this way. This will just be for testing purposes, and then we can pull it out after we're done. Self tile contains key, right? And then this can go away. And that way we can take a look at what it looks like. We'll say cave.display, no, part1.display. We'll say part1.drop1. And then part1.display again. All right, and so drop 1 is just going to drop one piece of sand. And we should see this as the output. So let's see if that happens. So fn drop 1, not self. And we always drop from 500 comma 0. So let mut sand is equal to 500 0. So now we need to figure out how to drop. We want to see if we can drop. While let sum next pause is equal to self fall sand. While the sand can continue to fall, we'll get the next position, and then we'll just say sand equals next pause. Once it can't fall anymore, we'll say self tile insert pause of a piece of sand, and then we're done. So now we just have to write fall, fn fall, self. It doesn't need to be mutable, but it does need to return an option of i32, i32. I should make this tuple a type so I don't have to keep doing it. But so what are we going to do? We always go down one if we can. Then we always go down one step, then we go down one to the left, and then down one to the right. Okay, so why don't we do it this way? We can say let mut new pause. No. We can just do it this way. We can say for delta x in minus 0 for falling straight down, -1 for falling to the left, and 1 for falling to the right. Let new pause is equal to, we have to give it a position. Sienna Burnt, thank you for the follow. Much appreciated. I'm guessing that's a Crayola crayon reference, Burnt Sienna? Or I guess it's just a color, paint color reference. I'm lost now. New pause. Oh, right, delta x. So it's pause plus delta x, comma, pause of 0, delta x, comma, pause of 1 plus 1, because we're always falling down by 1. And now we have to check to see if we can actually use that pause. If self.tile, if it doesn't contain the key, then we're going to say return some new pause. If it does contain the key, then we're going to loop to the next delta. And if we get through the entire loop without finding a spot, we'll just say none. Does that look right? I think that looks right. Of course it doesn't. Oh, this is sand. And then we can't clone cave. Not yet, but we will. There we go. So that built. It's computing. Oh, I should print out where the sand is. I don't see the insert, so I guess that failed. Because this should have worked here. Oh, you know what? Yeah, no, that's right. So we return a new pause each time. I was thinking, oh, we're not adjusting the sand. Oh, what we have to do is, yeah, we have to check to see if we get all the way to the bottom. There has to be a stopping condition, right? Well, okay, let's say print dropped to next pause. Maybe I got a failure at there. I'm also going to change this, so I'm going to say if x equals 500 and y equals 0, then it's going to be the plus sign, and then else if. And I'm just going to print a dash here just to separate the two prints, so we can see that. Oh, I meant to do that here, like that. But I don't see any drops, so maybe this failed right away. Really? Okay. It shouldn't contain any of the keys. I can let's say checking new pause. So we should at least see this, right? All three are wait a minute, that doesn't make sense. If self-tile contains, if it doesn't contain the key, oh, I have to return it. What a maroon. There we go. Although it's showing this. Oh, you know why? Because I didn't do this. If let some ch equals this, then ch. Oh, it doesn't like that? There we go. Okay, so now we see the 0. Let me get rid of these extra print statements here. And I don't need to display the first one. Where are we doing that? Here. And that way we can line it up and take a look. So there's 1. Right? And I think that matches this, right? Oops, this one. All right, let's drop a second one. And see if that updates. Yep. Okay, so and it fell to the correct location. And it says after a total of 5 units. Okay, let's do 5. Oops. That looks right. All right, after a total of 22 units, let's do 22. Oh, look at that. Beautiful. It's a beautiful thing. All right. Only 2 more units of sand can possibly come to rest. Okay, so 24. And it's going to be over here and over here. And there they are. Okay. Once all 24 units of sand shown above have come to rest, all further sand flows out the bottom. Ah. All right. We don't want to do that yet because we need to check to see if it flows out the bottom. How many units of sand come to a rest before sand starts flowing into the abyss below? Perfect. Okay. So we want to stop here. Oh, we want it to return. Let's return a bool. After dropping 1, we can say, did it fall off the bottom? Or did it successfully come to a rest? We can say if next pause dot 1 is greater than. We need to keep track of where the bottom is. Self bottom. Return false. And then this is just true. And now we need to add a bottom. Which means when we're drawing the lines, we can keep track of where the bottom is. Self.bottom is equal to self.bottom.max of start.1.max of n.1. A little overkill, but that should keep track of where the bottom is. And then when we detect that it falls off the bottom, it'll return false. So now we should be able to do it this way. We should be able to say while part1.drop1 count plus equals 1. And we can just output count. Let's see if that's an infinite loop or if that's a solution. Oh, there we go, 24. Okay. So let's do with the real input and see what happens. Input /2022 14.text. What do we get? 817. Oh, right. Yeah, this is just printing out one small section of it. Okay, let's see if 817 is right. Huzzah! We got one more star. We're at 27 stars now. Okay. Let's check with Clippy. Clippy has an idea of not putting just double quotes in there. There we go. Git status, git add source, git commit. SM 2022, day 14, part 1. All right, let's take a look at what part 2 has to offer. You realize you misread the scan. Oh boy. There isn't an endless void at the bottom of the scan. There's a floor, and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y-coordinate equal to 2 plus the highest y-coordinate of any point in your scan. In the example above, the highest y-coordinate of any point is 9, and so the floor is at y equals 11. This is as if your scan contained one extra rock path, like negative infinity, 11 to infinity, 11. With the added floor, the example above now looks like this. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at 500, blocking the source entirely and stopping the flow of sand into the cave. In the example above, the situation finally looks like this after 93 units of sand come to rest. All right. So we do need like some sort of a flag to indicate part 1 versus part 2, because this only applies to part 1. We don't want to return false for part 2 unless, all right. Create a flag called has floor. And that's just a bool. It'll start off as false. And so this is not self has floor end. Right, so this should still output 800 and whatever it was, 17. Yeah. Let's get rid of the display for now, because we don't need it for the big input. And I don't think I'm going to use it for the small input either. All right, and then part 2 is basically cloning this again, right? It's basically this. Except all the part 1s are part 2. But we're going to set part 2.hasFloor equals true. And now all we have to do is change the drop logic. Oh, we have to change the end logic here. So if self has floor, and oh, no. We'll do it this way. We'll say if self.tile.contains key of sand, right, at the 500 0, if it contains the key, then we're going to return false. I have to actually return it. And then here for part 2, we just need to check to see if we hit next pause, if self has floor and sand.1 is equal to self bottom this is self bottom, so self bottom plus 2. Then break. And then we'll just insert it because we found a location for it. Oops. Gotta spell it right. Should I run it on the test input first? Because this, well, we got a number. We're going to try the number, and if it's wrong, then we'll go back to the test input. Because it should be 93 for the test input. Yeah, okay, so let's figure out with the test input. Let's do it this way. And then we can print it, we can use the display thing again to print it out. We got 111 instead of whatever it was. So let's do that, and let's put the display back in. And we're going to make it wider, apparently, and taller. So this will be self bottom plus 2. And instead of 494, let's, I don't know, what does that look like to you? Let's do 480 to 520. That'll be 40 wide. That's wider than it needs to be. That's fine. Okay, and let's take a look at what did we do wrong? Oh, we went too far with the, okay, so that should be bottom plus 1. Right, because we don't want to put sand on the floor. Right, and now it's 93. Okay. Glad I left the display code to take a look at that. All right, so now let's use the real input. Try again. Two, 3, 4, 1, 6. That's definitely smaller than the other one. Yes, okay, good. That was a lot of fun. I enjoyed that one. Oh, is this us entering the cave here? Interesting. And we still don't know where the elves are yet. I don't know if the distress signal is from the elves or if it's from somebody else that we need to rescue first, and then we'll meet up with the elves later. There aren't too many days left, so hopefully we figure it out soon.